They said this land was finished, not damaged, not degraded, but finished. Soil so eroded that rain no longer soaked into it, but ran off the surface like water on concrete. A landscape stripped down to dust, where roots could not hold, and nutrients could not stay long enough to matter. Scientists gave it a word that sounds permanent: unsalvageable. Land that could no longer be repaired, restored, or brought back into use by any known method of modern agriculture. And yet, food returned to it, not through innovation, not through chemicals, not through machines, but through something older than agronomy, older than development programs, and older than the idea that soil is just an inert surface waiting for inputs. To understand how that happened, you have to go back long before anyone called this place a disaster. The Loess Plateau stretches across northern China, covering parts of several provinces and forming one of the most historically important agricultural regions on Earth. For thousands of years, this plateau fed early Chinese civilization. Its soil, known as loess, is a fine, wind-deposited sediment that is naturally rich in minerals. When stable, it is among the most fertile soils on the planet. Entire dynasties rose on food grown from it. The problem is that loess only works if it stays still. Once exposed, loess erodes faster than almost any other soil type. It does not crumble slowly. It collapses. When rain hits bare loess, it dissolves into suspension and is carried downhill in massive volumes. Over centuries, the people who lived on the plateau understood this. They did not treat the land as something to be conquered, but as something that had to be shaped carefully to survive. As early as the Qin dynasty and later expanded during the Han dynasty, farmers carved terraces by hand into hillsides. These were not aesthetic choices. They were hydraulic systems. Terraces slowed water, reduced slope, length, trapped sediment, and forced rain to soak into the ground instead of escaping. Farmers planted grains like millet and wheat, suited to dry conditions, and accepted lower peak yields in exchange for long-term stability. Crop residues were left on the soil. Grazing was controlled. Trees were not cleared indiscriminately. The system worked because it respected one rule above all others: gravity always wins. For nearly 2,000 years, this balance held. Then, history broke it. The collapse did not come from ignorance, but from disruption. Wars, population pressure, deforestation, and political upheaval dismantled the communal systems that maintained terraces and controlled land use. Forests were cut to fuel armies and cities. Farming expanded onto steeper and steeper slopes. Traditional maintenance stopped. Terraces collapsed and were not rebuilt. When the vegetation cover disappeared, the loess was exposed, and the land began to move. By the late Imperial period and accelerating into the 19th and 20th centuries, erosion reached a scale never seen before. Each year, enormous volumes of soil were carried into the Yellow River, turning it into one of the most sediment-loaded rivers on Earth. Floods became more destructive. Fields thinned until only a hardened crust remained. Villages were buried or abandoned. What had once been one of the great breadbaskets of civilization became a symbol of environmental collapse. By the mid-20th century, experts examining the plateau reached a grim consensus. The erosion was too severe. The soil profile was too damaged. The slopes were too unstable. This was not degraded land that could be improved. It was dead land, unsalvageable. Modern agriculture responded the only way it knew how. Heavy machinery was introduced to reshape slopes and increase efficiency. Chemical fertilizers were applied to force yields out of exhausted ground. Development programs poured billions into the region, assuming the problem was a lack of inputs rather than a broken system. But the machines compacted the soil even further. Fertilizers washed straight into rivers. Water still ran off. Yields rose briefly and then collapsed again. The land did not recover because the forces destroying it were never addressed. What no one wanted to admit was that this was not a technological failure. It was a philosophical one. The land was being treated as a surface instead of a living structure. Methods that once kept it alive were dismissed as backward because they did not scale quickly, did not generate profit, and did not rely on purchased inputs. They required time, labor, and restraint. In other words, they required everything modern systems are designed to eliminate. By the end of the 20th century, the Loess Plateau stood as a warning, a place where modern science had measured everything, modeled everything, and still concluded that nothing could be done. And yet, quietly, away from global attention, something began to change. Not because new technology was invented, but because old rules were remembered. The shift did not begin with an announcement, a policy paper, or a breakthrough study. It began with a quiet reversal of assumptions. Instead of asking how to force productivity out of damaged land, farmers and planners started asking a more uncomfortable question. What if the land never needed to be forced at all? The first rule that returned was also the simplest. Water must be slowed before anything else can live. On the Loess Plateau, erosion was never caused by lack of rain. It was caused by rain moving too fast. For centuries, traditional farmers understood that every drop that escaped downhill carried soil with it. So they stopped the water, not with concrete, but with shape. Terraces were rebuilt by hand across slopes once considered beyond recovery. Not shallow steps, but carefully graded platforms designed to interrupt gravity itself. Each terrace shortened the slope, reduced the speed of runoff, and turned rainfall from a destructive force into stored moisture. Where machines had flattened land and compacted soil, hand-built terraces loosened it. Where fertilizers washed away, water now stayed. But terraces alone were not enough. The second rule was even more important. Bare soil is dying soil. For decades, land had been left exposed between planting seasons. Wind stripped it. Rain dissolved it. The old system had never allowed this. Farmers began reintroducing continuous ground cover. Crop residues were left in place. Grasses were planted where crops could not survive. Trees were reintroduced not as timber, but as infrastructure. Roots became anchors. Organic matter became glue. Soil that once moved like powder began to bind again. One of the most radical changes was the restriction of free grazing. For generations, goats and sheep had stripped young vegetation before it could establish. Traditional systems had controlled this through communal rules that limited when and where animals could feed. When those rules collapsed, so did the land. Their return was controversial, unpopular, and resisted. But without them, restoration was impossible. Vegetation had to be allowed to grow long enough to protect the soil beneath it. As these rules returned, something unexpected happened. The land responded faster than anyone predicted. Rain that once vanished in minutes began soaking in. Infiltration depths increased year after year. Soil moisture stabilized. Springs that had dried up decades earlier began flowing again. Farmers noticed that wells no longer dropped as sharply during dry seasons. Crops that previously failed even with fertilizer began surviving without it. What modern agriculture had treated as a chemical problem revealed itself to be a biological one. As vegetation returned, microorganisms returned with it. Organic matter increased. Soil structure rebuilt itself from the inside out. This was not regeneration in the sense of restoration projects measured in centuries. This was recovery measured in seasons. Fields that had produced nothing began producing modest harvests. Modest harvests became reliable ones. Reliable ones became abundant enough to matter. By the late 1990s, the change was impossible to ignore. Satellite images showed something no expert had predicted. Large sections of the plateau were turning green, not temporarily, permanently. Where erosion gullies once dominated the landscape, stable slopes now held crops and trees. Where dust storms once originated, vegetation now anchored the soil. Independent measurements confirmed what farmers already knew. Sediment flowing into the Yellow River dropped dramatically, in some areas by more than half. Agricultural yields rose without corresponding increases in chemical inputs. Water retention improved across entire watersheds. The plateau was no longer bleeding soil into the river system that sustained millions downstream. This forced a quiet reckoning. The land that had been labeled unsalvageable had not changed. The approach had. What restored the Loess Plateau was not a single invention, a single expert, or a single institution. It was the reassembly of a system that modern thinking had dismantled. A system built on slowing water, covering soil, respecting slope, and allowing biology to do work no machine could replicate. And this created a problem that modern science struggles with, because there was no product to patent, no chemical to sell, no machine to scale. The most effective tools were time, labor, and restraint. The exact things development models are designed to minimize. The restoration of the plateau did not prove that science was wrong. It proved that science had forgotten history. It had measured the land as it existed after collapse and assumed that state was natural. It had mistaken damage for destiny. By the early 2000s, what had once been called the most eroded landscape on Earth was being cited as one of the largest ecological restorations in human history. The irony was unavoidable. The solution was not new knowledge. It was remembered knowledge. Knowledge that had been dismissed as outdated because it could not be monetized or accelerated. The land did not need to be saved by technology. It needed to be given back its rules. What followed was not just an environmental recovery. It was a social one. As the land stabilized, Villages that had been shrinking for decades stopped emptying. Families that once depended on seasonal migration began staying year-round. Food security returned slowly at first, then decisively. Farmers who had survived on emergency aid began producing enough to sell, not at industrial scale, but at a scale that mattered locally, which turned out to be the scale that actually sustains people. The numbers told a story no narrative could soften. In restored areas, vegetation cover increased dramatically within a single decade. Soil erosion rates dropped by tens of millions of tons per year. Sediment loads in major waterways declined enough to reduce flood risk downstream. Agricultural productivity rose not because yields were maximized, but because failure became rare. The land stopped collapsing every time the rain came. Perhaps the most overlooked change was underground. As water infiltration improved, groundwater systems began to recharge. Wells that had been unreliable for generations stabilized. Springs returned in places where no one alive remembered them flowing. This was not irrigation. No pumps were installed. No canals were dug. The water had always been there. The soil had simply lost the ability to hold it. This is the part modern agriculture struggles to explain, because it exposes a contradiction at its core. The restoration worked precisely because it removed dependence on constant inputs. Fertilizers became less necessary as organic matter returned. Pest pressure decreased as biodiversity increased. Crops did not need to be pushed to their limits to survive. They needed a system that did not collapse around them. The land recovered not because humans did more, but because they did less of the wrong things. And that raised an uncomfortable question. If land labeled unsalvageable could recover this quickly without advanced technology, why had it ever been written off in the first place? The answer lies not in ignorance, but in incentives. Modern agricultural science is optimized for scale, speed, and output. It excels at increasing yields where systems are already stable. It struggles with landscapes that require restraint, patience, and limits. Techniques that work slowly, require local labor, and produce no sellable product are difficult to justify inside models built around growth and return on investment. The methods that restored this land could not be patented. They could not be centralized. They could not be outsourced. They required communities to maintain them continuously. That makes them powerful, but it also makes them invisible in systems that measure success in quarterly results rather than generational stability. This is how land becomes labeled dead, not because it cannot recover, but because recovery does not fit the framework used to evaluate it. The story of this restoration forces a redefinition of what primitive actually means. These methods were not simple because their users lacked intelligence. They were simple because complexity already existed where it mattered most, in soil biology, hydrology, and ecological balance. The human role was not to replace those systems, but to stop breaking them. What modern science eventually acknowledged was not that the land had been saved, but that it had never been beyond saving. It had been pushed past its limits, abandoned, and misdiagnosed. The cure was not innovation, but humility. Today, this restored landscape is often cited as proof that large-scale environmental collapse can be reversed. But that framing misses the deeper lesson. This was not a rescue mission. It was a correction, a return to rules that had worked before anyone tried to improve them. Dead land did not come back to life because someone invented something new. It came back because people stopped, pretending they were smarter than gravity, water, and soil. And that leaves a final, uncomfortable truth. If land like this can be restored using knowledge that already existed, then the greatest barrier to recovery elsewhere is not technical. It is cultural. It is the refusal to accept that progress sometimes means remembering what was deliberately forgotten. The restoration of this land is often presented as an environmental success story, but that framing is too small. What actually happened here challenges the way modern societies define progress, intelligence, and value. Because if land declared unsalvageable can recover without new technology, without chemicals, and without massive financial investment, then the crisis facing global agriculture is not a lack of solutions. It is a refusal to accept the solutions that already exist. Across the world, soils are thinning, compacting, and losing their ability to hold water. Each year, more land is added to the eroded category of degraded or lost. The response is almost always the same. More inputs, more machinery, more complexity layered on top of a failing foundation. But the Loess Plateau revealed something deeply inconvenient. Complexity does not repair collapse. Structure does. Water must be slowed. Soil must be covered. Roots must be allowed to anchor the land. These are not innovations. They are rules. And rules do not generate profit. They generate stability. That is why these methods are so often dismissed as primitive, not because they are ineffective, but because they cannot be owned. They do not require licensing. They do not create dependence. Once communities understand them, they no longer need external rescue. From an economic perspective, that makes them invisible. From a human perspective, it makes them powerful. Modern agriculture did not fail because it lacked data. It failed because it forgot limits. It treated land as something to extract from, rather than something to maintain. When those limits were exceeded, the land was blamed. It was called poor, exhausted, unsalvageable. The possibility that the system itself was flawed was rarely considered. What this restoration proved is that soil does not die easily. It degrades when its structure is destroyed, and it recovers when that structure is rebuilt. The timescale is not geological. It is human. Years, not centuries. Seasons, not eras. The idea that collapse is permanent is comforting because it removes responsibility. If land is truly dead, then nothing more can be done. But if it can recover, then ignoring the rules that allow that recovery becomes a choice. The most unsettling part of this story is not that the land came back to life. It is that it never needed saving in the way modern systems assumed. It needed space to function, and people willing to work with it instead of against it. The techniques that restored it were never lost. They were sidelined, labeled outdated, and replaced by faster methods that worked briefly and failed permanently. This is how knowledge disappears, not through malice, but through incentives. What cannot be scaled, monetized, or accelerated is pushed aside, even if it works better than everything that replaces it. Over time, that knowledge is remembered only after collapse forces the question that was avoided in the first place. The land was called dead because it no longer served the system. Built on top of it. When the system changed, the land responded. That is the real lesson here. Dead land is often not dead. It is land that has been misused, misunderstood, and then abandoned when it no longer produces on command. Restoration does not begin with invention. It begins with restraint, with the willingness to accept that the most advanced solution is sometimes the oldest one still standing. If this story feels uncomfortable, it should, because it suggests that many of the crises we call unsolvable persist not because solutions are missing, but because they are inconvenient. They require patience instead of speed, limits instead of growth, and humility instead of control. The Loess Plateau was never restored by beating nature into submission. It was restored by stepping back and letting rules that predate modern science do their work. The land responded not to force, but to structure, not to innovation, but to memory. This is what lost wealth nature is about. Not hidden resources, but forgotten systems. Not lost land, but lost understanding. Because sometimes the most powerful form of progress is not discovering something new, but recovering what was deliberately left behind.